Hi everyone, my name is Chad Netwig, a software developer for a startup company called Q&A. I just recently finished an exciting project where I migrated an entire MongoDB, Express, Angular, Node.js mean full stack web application from a local server over to the cloud using Amazon Web Services AWS Cloud Platform. In this presentation, I will share various key details with you about the cloud migration process and cloud platform concepts that I think you'll find both valuable and interesting. For example, I will discuss concepts like containerization, orchestration, serverless computing, fully managed cloud database services, and principles of cloud-based development. Re-architect and lift and shift are two common models to migrate an on-premises full-stack application over to the cloud. Re-architect involves refactoring the existing code base before moving the application to the cloud in order to leverage cloud-native features such as serverless and storage services. However, refactoring is time-intensive. The lift and shift approach migrates the application to the cloud as is, without code-based refactoring. The trade-off here is that it is fast and easy to migrate, but it does not leverage the cloud services like Re-architect. Containerization is the packaging together of application code with all its necessary components like libraries and dependencies so that they are isolated from the infrastructure, making them portable across multiple platforms. Containers are a great choice for lift and shift. Docker is a tool used to package and deploy an application as a container. The Docker engine sits between the apps and OS to provide OS-level virtualization to divvy up OS resources for each app. Virtual machines are more resource-intensive, with guest OSs required for each application. Orchestration is commonly used to deploy applications developed using the microservices architecture, which are typically containerized. Docker Compose, for instance, is an orchestration tool used to spin up multi-container applications onto a virtual network wherein they can securely communicate. For example, this migration project involved forking a mean stack from GitHub, containerizing it with Docker, and deploying it with Docker Compose. The orchestration involved writing two YAML Docker Compose files to launch the containers as microservices to handle the backend and front end of the mean stack. Serverless computing is a cloud computing execution model that takes code packaged as a function and once triggered by an external event, executes it by automatically provisioning server resources. Serverless platforms auto-scale the applications based on usage and charge for the duration of the execution, usually in milliseconds. Amazon Simple Storage Service, S3, is file storage in the cloud. S3 uses a pay-for-what-you-use model, making it highly cost-effective on the order of a few pennies per gigabyte per month. Compared to local on-premises storage, all data in S3 are stored in buckets that in turn hold objects. The objects are logical hard drives consisting of many physical persistent stores distributed over several availability zones that can hold an unlimited number of objects, giving rise to high durability and availability. Amazon API Gateway used in conjunction with a serverless platform like AWS Lambda has several advantages. For example, since Lambda is event-driven, it requires a trigger to provision server resources and execute the code. API Gateway can provide this trigger. API Gateway also provides intrinsic security because it essentially functions as a firewall between the public end users and the backend Lambda logic. For this project, the API Gateway was used for separation of concerns to sit between the front-end and back-end logic. I integrated the back-end by implementing various Lambda functions using Node.js scripts to perform CRUD operations on two tables that I configured in DynamoDB. I then established API REST endpoints in Amazon API Gateway and integrated them with Lambda via proxy integration to trigger the respective Lambda functions. I also modified the Angular TypeScript logic stored on the S3 static website bucket to integrate with the API REST endpoint so the front end could access the backend logic. The image shows the full stack logic flow from the front end with a browser sending an HTTP GET request to the API endpoint, triggering the Lambda on the back end, that in turn queries DynamoDB, which returns the data back to Angular to update the browser. DynamoDB uses a single table data model to store multiple entities, which logically group the items of that entity by a partition key. In contrast, MongoDB uses a data model that normalizes the data into separate tables, one for each entity, and uses auto-generated IDs to uniquely identify items in the table. For this project, for example, I created a Lambda function for each DynamoDB CRUD operation. For example, I created a Lambda function called findOneQuestion, which uses Node.js code to query a single item in a DynamoDB table. Generally, the code logic does the following. Instantiates the DynamoDB.documentClient class to use to hold the data returned from DynamoDB. Okay, it declares a query database method that takes the table name as a parameter and calls the document client scan method to initiate the database query. Finally, it declares exports.handler, the code executed when the Lambda function event is triggered, which then calls the query database method to perform the actual query. So the code is shown to the right here and how this is done. Elasticity is a common concept to cloud computing platforms like AWS. Elasticity means that infrastructure resources like CPUs, RAM, storage, etc. will automatically fluctuate based on the demand of those resources at any point in time. For example, if a website that has intermittent spikes in usage is hosted on a virtual machine in an Amazon Elastic Compute cloud instance, the instance will scale up by automatically provisioning more resources. The pay-for-use model is also common to cloud computing platforms where the cloud account user is charged only for the resources they use on the platform. This reduces the risk of under or over provisioning resources to adapt to fluctuating needs. Businesses using traditional on-premises servers must forecast future usage demand, which is largely guesswork. The image to the right demonstrates this guesswork, with the red line showing actual usage and the blue planned resource capacity. The blue above the red is over-provisioning, and the blue under the red is under-provisioning. AWS is secure by default, meaning access must be explicitly given to resources. AWS uses its Identity and Access Management IAM service to control access. An identity in IAM is either a user or role that can be associated with policies. Policies provide the low-level permissions to allow or deny specific actions to AWS resources. Roles are a collection of policies that can be assumed by users or services to provide temporary access to resources. For example, I needed to give the Lambda functions access to DynamoDB. To do so, I first created a policy that allowed query actions to DynamoDB resources, then attached the policy to each Lambda execution role to grant them access. The image represents this concept with an IAM key between Lambda and DynamoDB. I also configured and attached a policy to allow public access to the AWS S3 bucket that hosts the front-end Angular SPA. As shown in the image, the IAM key between the API gateway and Lambda gives explicit permission between the two. To do this, I configured this access with Lambda proxy integration with the API gateway. Throughout this presentation, we have seen many great features that a cloud platform like AWS provides the cloud developer. Containerization and orchestration allows microservices applications to be infrastructure independent so it can run on different platforms. The function as a service platform, Lambda, allows microservices applications to use compute resources only when they are triggered by an event, such as a call to a REST endpoint. Finally, we have seen how AWS implements the best practice of the principle of least privilege into its services with zero access as default security. I want to take the opportunity to thank you very much for taking this journey with me on how I migrated a full stack mean application to a serverless cloud platform using cloud storage and a cloud database. Thank you very much.